Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Rippleflux by Aeon. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9, such that there are no repeats in any row, column, or designated 9-cell region, which is a box in this instance. Lime green lines are region sumdex lines. That is, they both act as a region sum line and an index line. A region sum line, so all of these green lines are essentially both a region sum line and an index line. So the rules for a region sum line is the sum of the digits on a line segment is the same for each box it passes through, and different lines may have different sums. So, for example, on this line, these two cells must sum up to the same sum as these two cells, which must sum up to the same sum as this cell. These two cells must sum up to the same sum as these two cells, which must sum up to the same sum as these two cells. These three cells must be the same sum as these three cells, which must be the same sum as these three cells, etc., etc. So that's how region sum lines work, which all lines are, remember. And also all lines are index lines, where starting from the circle, the digit in the nth cell along the line indicates the position along the line where the digit n appears. So for example, if this were, say, a 6, that would mean the 1, which is the first position it's in. This is the first cell, shall we say. That means the 1 has to be in the 6th position along this line. It also means that 6 is in the first position, so therefore that would satisfy both of these index lines. So if this is a 6, that means 1 has to be in the 6th position. That forces 1 to be here, which means that 6 has to be in the first positions. So it's basically mutually defining itself, I guess. And remember, all index lines all green lines are both index lines and region sum lines. Also, as a hint, not a hint, but basically, you might get confused about this. You cannot reference a position that is outside of the line, because that just doesn't work. So that should give you a hint about how you can restrict things on index lines. Anyways, those are all the rules. If you like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. So, because you cannot index things past the size of the line, right? Because you can only get to the 6th position. That means on this 6-cell lime green line or index line, it must be the digits 1 through 6. This is 9 in length, so that could be the full 1 through 9. This is only 5 in length. So we know this must be a 5. Because these two must sum to these two, which must sum to that. Well, this is the largest digit then, so this must be 5. This cannot be 2 and 5 as a pair. These have to be 1 through 4 then. But we know 5, this 5 says that 1 has to be in the 5th position. So this is 1. That means 1 and 4 add up to 5. And this is 2 and 3. So this is a 2-3 pair here. Okay. This cannot be 1-6 or 3-4. So this has to be a 2-5 pair here. That means this is the 6th position. So 5 has to be in either the 5th or the 6th position. Well, it can't be the 6th because this can't be 6. So this must be a 5, which makes this 2. That's saying that 6 has to be in the 2nd position. That forces this to be 6. Oh, and the reason why we know all this is because on an index line, you have to have one of every digit from 1 to n, where n is the length of the line. And the reason why is because you can't have two digits pointing to the same digit on the positioning, right? If you say you had a 2 here, a 2 here, and a 2 here, that would say that 1 has to be in the second position and 6 has to be in the second position, which is not allowed. Even if you had 2 here and 2 here, that would also say 2 has to be in the second position and 6 has to be in the second position, and that's not allowed, right? So this is 6, which forces this to be 1 to add up to 7, because these all must add up to 7, because these are the digits 1 through 6, and it's divided into 3 different segments. So they must add up to 7. This then must be a 3-4 pair. This can't be 4 because of the 4 in the column, so this is 3, this is 4. Right, so 1 is saying 1 is in the first position, which it is. 6 is saying 2 is in the sixth position, which it is. 3 is in the third position, 4 is in the fourth position, 5 is in the fifth position. This 2 eliminates 2 here, so that's 3, which makes that 2. 5 is in the first position, and 1 is in the fifth position. 2 is in the second position, 3 is in the third position, 4 is in the fourth position. So these must add up to 15. These must be the digits 1 through 8. So this has to be 2 and 3 here. So that means it's what? It's 1 through 8. That's 36 divided by 2, which is 18. So 2 and 3 have to be here. Okay, where is the 3 in? So 3 has to be on this index line. It has to be one of these 3. Cannot be any of these because it all sees the 3 here. That means where's 3 in row 3? Cannot be here because of 3 in the box, but can't be here because of the 3 has to be on the index line. So it has to be one of these 3. Can't be here because that's filled out. This 3 eliminates 3 here, so this must be 3 here. This is 2 also. So 2 and 3 have to be these cells. That means this cell is, so the second position means this is 2, where 2 has to be. So 2 can be in 5, 6, or 8. And 3 can be in 5, 6, or 8 here. Okay? This 2, 3 must sum up with 2 other digits to add up to 18, I believe, right? 36 divided by 2 is 18. So 18 minus 2 and 3, which is 5, is 13. So 1 can never be here. Therefore, 1 has to be in this portion of the line. That means this is 1 here, because 1 can't be here, 1 can't be here. That's saying 4 has to be in the first position, so this is 4. These add up to 5, so these two must add up to 13 also. And it can only be 5 and 8. Therefore, 5 and 8 have to be 2 and 3. And this must be a 6, 7 pair. And that satisfies that. Okay. This adds up to 15 without 3, 4, or 5. So if it doesn't have a 1 or 2, excuse me, if it didn't have a 1 or 2, it would have to be 6, 7, 8 at minimum, which is 21, which is not what this region sum line can add up to, right? It's 45, right? It's the digits 1 through 9, which sum up to 45, divided into 3 segments. So 45 divided by 3 is 15. So that's why this must add up to 15. So it has to have a 1 or 2. If it's 1, it could be 168, and that's it. Cannot be 159. Yeah, 168 is the only possibility for 1. So if this were neither of these, this can't be 1 here. So we're guaranteed a 1 or 2 here. If 1 or 2 were here, that would force 3 to be one of these cells, which is impossible. So 1 is either here, which would force this to be a 6-8 pair. Or we have a 2, which would have to be here. 2 cannot add up with, it has to be 6 and 7, I believe. Right? Yeah, it could be 6 or 7. Obviously it can't be 2, 4, 9, 2, 5, 8. Yeah, it has to be 2, 6, and 7. So this one of these is guaranteed to be a 6. So one of these is a 6, which means there cannot be 6 on the rest of this sumdex line. Okay. Remaining digits in up box 3 are 1, 4, 5, 8, 9. And 1, 4 cannot be here because of the 1, 4 in the row. This can't be 5. So one of these 2 is a 5 here. Remaining digits in box 2 are 6, 7, and 9. So this is 7, 9, 6, 7, and 9. So 6 is one of these 2 digits. Remaining digits in box 1 are 6, 7, 8, 9. Okay. That means in column 3, the 1 and 2 have to be in box 7, guaranteed. So again, this could be 168 or 267 here, adding up to 15. The 9 cannot be in 1, 2, 3. It can't be a 6 because of the 6 in the row. So it has to be 4, 5, 7, 8 as possibilities for where the 9 is. So 9 can be one of these 2 or one of these 2. Okay. This is 1, 2, 3, 4, 5, 6, 7. Wait, but this acts as a region sum line. Oh, that adds up to 28. So 1, 2, 3, 4, 5, 6, 7 adds up to 28. So this is 14, and this is 14. So these digits are 1 through 7. This can't be 1, 3, or 6, though. This can't be 4 or 5. One can only be in 1. It can't be in 2, then. It could be 3. No 4, no 5. It could be 6 or 7. So 1, 3, 6, 7. 2 could be in 2, which cannot be in 3. Could be 4, 5, no 6, and it could be 7. 3 could be 1, 3, 4, 5, 6, 7. That's fine. Okay. So 3 digits adding up to 14. Could be 1, 6, 7. So 6 cannot appear. We know 9 has to be one of these 3. And it's either with 1, 8, or 2, 7. So if it's 1, 9, 8, this would have to be 1, and this would be 8, 9. If it's 2, 9, 7, this can't be 2, so this would be 2, and this would be 7 or 9. So those are the possibilities. This cell can be only 1. Can't be 1, 2, 3. Because it would have to be there then. Could be 4. Cannot be 5 because that would force 4 to be there. Cannot be 6. It could be 7, 8, or 9. So this is 4, 7, 8, 9. What about 6 can only be in 1, 2, 3. So this is 1, 2, or 3. It cannot be in 1 because of the 1 in the column. So this is 2 or 3. So 6 cannot be here. Which means if this is 2, 6, 7, this is 2, this is 6, and that's 7. So this can never be 7 here. 3 can only be then in 6 or 8. So 3 has to be one of these two. 1 can only be 1 or 7. So that means 1 can only be one of these two cells. Which eliminates 1 in the rest of this row. So this cannot be 1. So therefore this can't be 3 because that 3 would force 1 to be in that spot, which is cannot be. This is 3 or this is 3, which eliminates 3 in the rest in this cell specifically because it sees both of them. That means 3 cannot be in the 4th position. This can't be 6 because one of these two is a 6. So 3 cannot be in this position. So that can't be 3. 6 could be in 1, 4, 5, 6, 7. That's true. Okay. So, right. 6 is one of these two, so 6 has to be one of these 3. This is 2 or 3 here. That's interesting. If this is 2, that means this must be 1, 6, and 8. So 6 would have to be here. So if this is 2, if this is 3, this could be still 1, 6, 8. Huh. So if this is 1, this cannot be 1, 6, 8 in this region sum line. It has to be 1, 5, and 9. But if this is 1, 5, and 9, the problem is the 5 says the 9 has to be in the 5th spot. But it's in the 8th spot, which is not allowed. So this can never be 1, which means this has to be 1, 6, 8. So this is 1, 6, 8 as a triplet, which eliminates 1, 6, 8 in the rest of the index line. So 9 can no longer be here. 3 is one of these two again. It's 6 or 8. 2 also has to be in 6 or 8. So this is 2 or 3 as a pair, which eliminates 2 and 3 in this cell. So this can never be 4 then. If this is 2, it has to be... It can't be with 6 or 8. So it has to be 2... can't be 2, 3, anything, because that would be 2, 3, 10. Could be 2, 4, 9. No 2, 5, 8. No 2, 6, 7. So 2 has to be with 4 and 9. So if this is 2, the problem is that would force this to be 4 and this to be 9. But then the 4 would, in the 9th position, would say 9 has to be in the 4th position, which is not allowed. So this cannot be 2. This must be 3, which makes this 2. So this is 2, 4, and 9. That means this is 3, 5, and 7. Well, 7 cannot be the 9th position, so this must be 5, and this must be 7. That's saying 9 has to be in the 5th position, so this is 9, and then this is 4. And that adds up correctly. This 9 eliminates 9 in the rest of the column. This 7 eliminates 7 in the rest of the box. And this 5 eliminates 5 in the rest of... Oh, that's a problem. We have a contradiction here. Okay, let's clear this again. 1 through 7. Okay, this cannot be 3, 5, or 7 here. This can't be 1 or 6. So 3 has to be either in 2 and 4, and that's a problem because it can't be either. Huh. That's problematic. Hmm. That couldn't even add up because that would be 2, 4, and 6 adding up to 12, which when it has to be 14. Okay. We messed something up. I'm not sure what. What did we mess up? Shoot. I don't know where to start then. This does have to be 5. Because if it's not 5, the digits 1 through the digits 1, 2, 3, and 5 would never add up to 4. So this has to be 5, which means 1 has to be in the 5th position. That's a 1 and 4 adding up to 5. 2 and 3 adding up to 5. This must be the digits 1 through 6. This can't be 1, 6 or 3, 4, so it's 2, 5 here. Again, 5 cannot be here because that would say 6 is in the 5th position, which is not. So this is 2, 5 here. That means 6 is in the 2nd position, so this is 6 and 1. And this is 3 and 4. That satisfies that. Again, 3 cannot be any of these. 3 definitely has to be here. 2 definitely has to be here. This is 3. That's fine. Where's 1 then? 1 cannot be here because 1, 2, 3, and another digit never adds up to 18. So this has to be 1 here, which means 1 cannot be here or here, so this must be 1, which means 4 has to be in the 1st position, so it's 4 and 1 here. This must add up to 13 to add up to 18, so it's 5 and 8, which means 2 and 3 are in the 5th and the 8th position, which is working. This is 6, 7, that's fine. So all of this is kosher. I still think, yeah, this has to be, okay. 6 can never be here. 2 can never be here. 3, 4, and 5 can't be here. 1, 6, and 8 are the possibilities, and 2, 6, and 7. Because you can't have 3, 4, or 5 in that box. And it adds up to 15. So you're guaranteed a 6 there. So this cannot be 6. Therefore, 6 has to be one of those 3. I don't know. Three is either here or here. Cannot be 4. If this is 1, 6, 8. Wait, why can't this be 9? Oh, that's where I made the mistake. This could be 9. I don't know why I said this can't be 9. This could be 9. Here. Okay, so that was the mistake I made. It can't be 1, 3, 6 here. It cannot be 2 because this cannot be 9 here. Yeah, that's the mistake I made. Okay. So 3 is either here or here. 6 or 8. If we try to have 1 here, I think, then it could be 5 and 9. Okay. Well, that's... Okay. Yeah, that was a mistake I made. I left out the 9 here. So these 3 could be 9, or these could be 9. Okay. This cannot, this is 2, 4, 5, 7. 1 can be in, cannot be in the second position. It could be 1, 3. Why is this not, why is this, This could be 1 also. Oh, no, this cannot be 4. So 1 can't be in the 4th position, 1 can't be in the 5th position. 1 could be any of these 4. 2 can be in 2nd, 4th, 5th, and 7th. 3 can be in 1, not 2. 3, this can't be 3 because there's 6 or 8 here. So this can't be 4. It could be 5. This can't be 6, so this can't be 3. And 7th. And 4 can be in 2, 4, 5, 6, 7. 5 can be in 2, 3, 4, 5, 6, 7. 6 can be in 1. No 2 or 3. 4, 5, 6, 7. And that satisfies that. And 7 can be in all those places. Okay, so what are the possibilities for this? For 1, this could be 1, 6, 8. If this is 1, 6, 8, that means 2 or 3 is here. Otherwise, it's 2, 6, 7. Which means this must be 1, 5, 9. Okay, so say it's 2, 6, 7. That's the easier one. 2, 6, 7 means this is 3. It has to be 4 and 8. This is 1, 5, 9. So this would be 1, because this is 2, 6, 7. 6 would have a 3, so it's 3, 4, 8. This would have to be 1, 5, 9. And it could, right? If this is 1, this can't be 5 because that would say 9 has to be in the 5th position, which it's already here. So this would be 9 and 5, if that's the case. If this is 2, 6, 7. If this is 1, 6, 8, we are guaranteed 7 has to be one of these 3 cells there. Because 2, if it's 2, 7, 9, this is 2, and that's 7, 9 as a pair. So this can never be 7. This 5, 8 pair eliminates 5 and 8 in the rest of the row, so this can't be 8. Interesting. Okay, so if this is 1, 6, 8, then that means 2 and 3 are in the 8th position. So 8 can only be in 2, 3, or 5. So this can never be 8 here. So if this is 3, 4, and 8, this has to be 3, 4, 8 here. If this is 1, 6, 8, we have 2 with 4 and 9, and 3 with 5 and 7. So we tried 3, 5, 7 here, and that just doesn't work. If this is 3, that eliminates 3 here. This is 3, 5, and 7, so that would mean that 3 had to be in the first position, which is not allowed. So this can never be 3 here. This is always 3 here, which makes this a 6. So this is 6. This cannot be 6 here. This is either 1, 8 or 2, 7 here. So we have 2, 7 here makes this 1, 5, 9. If this is 1, 6, 8 here, this has to be 2, 4, and 9. And 4 cannot be here because that would say 9 has to be in the 4th position, which is not allowed. So this is always 9 here then. That eliminates 9 in this spot. So this is either 3, 4, 8 or 3, 7, 5. And this is 1, 5, 9 or 2, 4, 9 here. Interesting. So that means 1 has to be one of these two, which eliminates 1 here. So 3 cannot be here. 3 can be in 3, 5, or 7. Okay. So this is 159 or 249 here. If this were 249, that means 2 would have to be here or here, which is possible. If it's 159, what does that mean? This is a 6-7 pair. That would eliminate 6 and 7 in the rest of the column. This 9 eliminates 9 in the rest of the column anyways. We need a 9 in row 6. It has to be one of those three. Oh, this 9 eliminates 9 here. Okay, that's good. Which means this has to be a 9 here. Which means where's the 1 in box 4? It has to be here. So this is 1 and 8. That makes this 2 and 4. This 8 eliminates 8 here, so it's 2. This can't be 8 here, so it's 7. This 9 eliminates 9 here, so it's 6, which means this can't be 6. That's 7, which makes that 6. 7 eliminates 7 here, so it's 9. These can't be 6. This can't be 8 because of the 8 in the column. These can't be 9 because of the 9 in the column. This becomes a 6-7 pair, which eliminates 6 and 7 in the rest of the row. So this can't be 7. So this must be 2, 4, 9, which forces this to be 3, 5, 7. The 4 and the 7 point to each other. The 9's pointing to itself. This can't be 2 or 4. That means 2 has to be either in 5 or 7. 5 cannot be either of these. This can't be 7. This can't be 4. So 4 must be in 4, 5, or 6. Actually, 7. This 7 eliminates 7 in the rest of the column. And the 6 eliminates 6 in the rest of the column. Okay, 1 can only be in 1 or 6. 2, 3, 4, 5, 6. Therefore, 1 has to be one of these two, which eliminates 1 in the rest of the column. 2 can only be in 5 or 7, so this is guaranteed to be 2. This can't be 1 here. 3 can only be in 3, 5, or 7. So that means 3 is one of these. This 5 eliminates 5 here, so that's 8, which makes that 5. That's saying 2 has to be in the 8th spot. So this is 2, this is 3. This 2 eliminates 2 here. So where's 2 on the index line? It has to be here. So this is 2, which means 5 has to be in the 2nd spot. So this is 5. 4 cannot be in the 5th spot anymore, so this can't be 5. This can't be 5. We have a 1, 4, 6 triplet on the index line. So that eliminates 1, 4, and 6 in the rest of the index line and the rest of the column. So this can't be 4, which makes this 8, which makes this 5. This can't be 5 or 8, so it's 9. This can't be 4, 8, or 9, so it's 1. This can't be 1, 8, or 9, so it's 4. This 8 eliminates 8 here, so it's 9, which makes this 7, which makes that 8. And this can't be 6 anymore. 1 is either in 1 or 6. 3 is in 3 or 7. 4 is in 4 or 6. 6 can be 1, 4, or 6. That leaves the remaining digit in column 8 as a 3. Therefore, this can't be 3. That's 7, which makes that 3. Remaining digits in row 6 are 5, 7, 9. And this can't be 7 or 9 because of the 7, 9 in the column. So this is 5, which eliminates 5 in the rest of the row. And the rest we're going to have to do from normal Sudoku. Remaining digits in column 1, we have 4, 5, and 8. This can't be 5 because of the 5 in the row. Remaining digits in column 2, 3, 6, and 9. 3 cannot be here or here, so this must be a 3 there. I think we have all the 3s now. We do not, but that's 8 3s, which means we know where the last 3 has to be. It has to be here. Remaining digits in column 3 are 1, 2, and 7. These can't be 7, this can't be 7. Where is a 7? It has to be here. So we have a 1, 2 pair here. Where is a 7 in box 6? It has to be here. Can't be here, can't be here, so it must be here, which means this can't be. Where is the 6 in row 4? Can't be here, and can't be here because of the 6 in the boxes, so it must be here. So this is 6, which makes this 4, which makes that 1. 6 is saying 1 has to be in the 6th spot. Where is the 2 in row 4? Cannot be here because of the 2 in the column. Can't be here because of 2 in the column, so it must be here. Remaining digits in row 4 are 1 and 8. This can't be 1 because of the 1 in the column, or the 1 in the box, so this is 8, which makes that 1. That leaves this as an 8. Where's the 1 in column 4? Can't be here because of the 1 in there in that row, so this must be 1, which makes this 2, which makes that 1. So we should have all 9 ones. We do. 2s. We have 8 2s. We know where the last 2 has to be. It has to be here. We have all 9 3s. 4. This 4 eliminates 4 here. But I don't think we have any additional information. We do. A little bit. Yes, we have a lot. Where's the 4 in row 5? It has to be here. Where's the row 4 in row 4? Column 4 has to be here, which eliminates 4 here. So this is 8, which makes this 5, which makes that 4. That should give us all the 4s, which it does. 5s. We have 8 5s. We know where the last 5 has to be. It has to be there. 6s. That's okay. The 6 in column 7 has to be here. That eliminates 6 here, so it's 9 and 6. That gives us 8 6s. We know where the last, 7 6s. So where's the 6 in row 8? Cannot be here because they're filled out. Can't be here because of the 6 in the box, so this must be a 6. That means this can't be 6. This is 7. That's 6. 7 eliminates 7 here, so it's 9 and 7. We should have 9 6s now. We do. We have 9 7s, so that's fine. 8s. The 8 in row 7 has to be here, because this is the only cell for it. We have 8 8s, so therefore that's an 8, which leaves the remaining digits as a 9. So that's the solution. Yeah, that was bad there. I don't know why I said this couldn't be 9. Not too hard though, but if you make a mistake like that, it becomes kind of problematic, I guess. Fortunately, I didn't have to go from the, well, I did essentially go from the very beginning of my mind, but I didn't have to clear everything, which is good, I guess. I don't know. I don't know how I removed that 9 there. It was, you have to be careful about those sort of things, but I'm not sure why I just didn't say 9 could be there. It was very weird. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.